Thank you so much for the invitation. Thank you for Mr. Abdullah for the introduction, and thank you also for the introduction to myself. And yes, I work with volcanoes. I have been working with volcanoes for some 25 years now, and I'd like to talk about the positive side of volcanoes increasingly more, because we all know about the dangerous sides of volcanoes. And just a few words about the problems volcanoes make. And here's some images from Europe, from Etna. And this is just from 2 years ago. Etna erupted very strongly. And of course, there's a lot of people living close to it. And this causes all sort of problems when we have volcanoes and humans interacting. So here's a few more images from Etna and also from Hawaii, where we have a clash of nature, volcanic forces, and humans. And this is, of course, something that we see very often in the media. This is very spectacular, and this is what most people think about volcanoes, and that is that volcanoes are bad. Volcanoes are a threat. And here's some impressions from Merapi, which just erupted a few days ago again. And Merapi is, of course, very dangerous. It's a very active volcano. And this is from 2006, the village of Kali Atem, which was largely wiped out. And these are images we all are familiar with. We're all aware of the dangers volcanoes cause. And there are some interesting voices here, but anyway, so we know that the volcanoes are causing all sorts of local hazards and also more distant hazards. And this goes from lava domes that collapse to lava flows, to pyroclastic flows, to lahars. And they all have slightly different hazard potential. But as soon as humans get too close to volcanoes, they are within the vicinity of the danger envelope, if you want to call it that. So, and we know, of course, volcanoes have also long-term effects. We know that large eruptions like Tambora and Krakatau, they have climate effects for years to come that also affect the weather. And therefore, we often experience negative effects from volcanoes. But my goal today is to talk about the other side of volcanoes, the good side of volcanoes. I think volcanoes have a somewhat bad reputation. And of course, if you are in an eruption, it is very dangerous and they deserve a bad reputation. It's important that we are careful with volcanoes. But I also think it is important that people know about the good side of volcanoes. And this is my goal today. So I would like to talk about volcanic resources, and I will use examples from all over the world, from old volcanoes and young volcanoes. And I want to bring to you all the interaction humans have, society has with volcanoes. So here's a little definition I produced about volcanic resources. Volcanoes and their underlying magmatic processes are the principal agents of redistributing materials within planet Earth. They are therefore a key feature in the understanding of the localized concentration of metals, minerals, fluids, and all of these things are crucial for humans that are dwelling on the surface of the planet. This is something people often forget. They don't fully appreciate that fact. And I think it's important we remind everybody of this today. So I'd like to start with metals, and I come from Sweden here, and Sweden is a very metal-rich country. It's one of the main mining countries in Europe, and here we had volcanoes as well. In fact, we had subduction zone volcanoes like Indonesia, but many, many millions of years ago, 1.9 giga years ago. And here is an open mine in North Sweden, and here's some of my students visiting the mine a few years ago. And here we produce a lot of metal, a lot of iron, but also copper and less silver, but also some lead. And all of these metals, they come originally dominantly from volcanoes. And I think it's important to point out that gold, silver, and copper, our main coinage metals, they're all made essentially in volcanoes, and they may be recycled in sedimentary deposits, but they originally are brought to the Earth's surface by volcanic activity. So when we think about our currencies, traditionally silver has been very important. Those countries that had a lot of silver, they were very rich. So Sweden had silver in the past, and that made Sweden very successful. South America had a lot of silver, and this made the Spanish Empire very rich. And of course, gold is another metal that's very important. Gold is chemically non-reactive. It doesn't react with anything else. So it's very stable as a currency. And of course, if you have bad teeth, then you might get a gold tooth as well. So, and this is because it doesn't chemically react. And therefore, you can have it in your mouth. It's good in this kind of respect. And I need to point out that we don't have a lot of gold. All the gold that was ever mined by humans on this planet actually fits in a cube of about 20 meters side length. So here's a little illustration. If we put all the gold ever mined into this cube, it's going to look very small next to a pyramid in Egypt. And there's a tiny dark figure there. It's the human figure in the image. So actually, we think there must be loads of gold, but it's not a lot on this planet. This is why gold is such a valuable commodity. And I should, of course, point out that we have a lot of metal reserves also in Indonesia, of course. There's the Grasberg mine, and most of you are aware of this. It's got huge reserves for copper and gold, and it's a ginormous mine. So this is something that we probably might have to exploit even more in the future. Grasberg type deposits that come originally from volcanic activity, and they deliver a lot of metals for global economy. So we produce a lot of iron, but a lot of copper as well, and we need a lot of copper for electronics, but iron is still the main metal we are mining, and iron is important for construction. If we build a bridge, if we build roads, if we build skyscrapers, we need iron. We need more iron than any other metal. There's a lot of discussion these days about rare metals, but iron will remain the main metal for many, many decades, and we will have to mine it in large quantities. But for increasingly more technological application, we need more sophisticated metals. We need rare earth metals for making our mobile phones, for making solar cells, for wind turbines, etc., etc. And here we have to, of course, look for volcanic deposits. And one future volcanic deposit that becomes very attractive right now, it's heavily discussed, certainly in Europe, and that is submarine deposits. And most submarine deposits are, of course, volcanic in nature. And here I show a black smoker from a mid-ocean ridge, and that has a lot of cobalt and manganese, and we need those elements, but also it has a lot of copper and lesser iron, but there's also some rare earth elements. And we might need to go and not only mine on land, not only volcanoes on land, but also volcanoes underwater. Here is a manganese crust on a submarine tuff. The lower part is the tuff with little lapilli, with little stones in there. And then we have a crust of manganese, and this is material that comes from these black smokers, and then it settles out and makes these crusts on the ocean floor. And they are very rich in these elements like cobalt and manganese that we need for our modern technology. So, but then in addition to metals, I also want to point out that volcanoes produce wonderful minerals. Many gemstones have to do with volcanoes. And here's a few kind of jewelry. There's the British crown jewels and also some others. And many of those stones are, of course, from some geological setting, and many are actually connected with volcanoes, either primary or secondary in terms of skarn minerals, where magma has interacted, for example, with sediments and created metamorphic reactions. And there we also have beautiful kind of minerals of different types. I don't have time to go into details here, But diamonds are, of course, the most important primary minerals that volcanoes produce. Diamonds need high pressure, and either we have meteorite impacts to make diamonds, or we bring them up from very deep within the planet by fast eruptions. And we have a lot of these kimberlites in old cratonic volcanism, like in South Africa or in Australia. And that's where we bring up these beautiful diamonds. And when we polish them and cut them, they become, you know, very shiny with beautiful faces. And they are extremely valuable. Again, they're valuable because they have a technical behavior that cannot be imitated by any other material, and that is they're extremely hard. They cut even glass, and that makes them extremely valuable. We can make diamonds industrially by now, but they're different to natural diamonds. Natural diamonds have different touches of color, and the specialists can easily distinguish artificial from natural diamonds. We use artificial diamonds for industrial applications, but natural diamonds are, of course, still used for jewelry and, for example, for making crown jewels and things like that. So, but in addition to the minerals, I'd like to also point out stones. And here, one of the most prolific type of stones that people have used for many, many centuries is, of course, obsidian, volcanic glass. Here's a few impressions. There's obsidian from Turkey from the 5th century BC before Christ. So this is 2,500 years ago. And there's also some examples from the ancient Mayans in South America. And all these people worked out quite easily that if you break volcanic glass, it makes very sharp edges. And you can use this as a cutting tool. And this can be used for knives, for arrowheads, for spear tips. And actually, believe it or not, there is certain surgeons that still use obsidian today because the cut is so clean. It's better than cutting with steel. So if you want to have a clean cut that heals very quickly, obsidian is still the choice for many high sophisticated surgeons in many applications in medicine. So because you will actually see that the obsidian breaks down to a single atom, to a single level atom, and that makes a very clean, sharp tip. And this is, of course, allowing these cuts to be very clean. In addition to that, I would like to point out that, of course, obsidian also makes beautiful jewelry. And I know that my daughters, for example, they love obsidian jewelry. And here's just a few examples to remind you of that. And many people say obsidian gives the wearer of the jewelry very strong powers, and it makes you strong because it comes from volcanoes. I don't know whether this is true, but it sounds beautiful. And I hope that people who wear jewelry, and particularly obsidian, will feel very positive about it. Now, there's other stones that are in use, and this is pumice stone. And pumice stone is a very bluffy, a very frothy volcanic material, often glassy, often very high in silica, and it has many of these bubble spaces. And okay, I'll just continue then. So, and people use this for abrasion material, to polish material, to polish surfaces. And this is often used in industry. Here's two examples. But this is also used in cosmetics. So here's a few examples. So here is some body scrubs. And here, if you look at the small print, here, it says there's ground pumice stone in there. And here it's the same. So here's some foot scrub, and it actually kind of contains pumice stone. And this one here as well. So it has pumice stone in it. And if you look very carefully, again, this one here, it also has pumice stone. And this one here even has a body scrub named Krakatoa after the volcano Krakatau. And it's supposed to contain volcanic pumice that will actually abrade the skin. And we all know this from the traditional applications. So here we have, for example, larger pumice stone to remove skin. And this is often actually even used in toothpaste. Toothpaste can have very finely ground pumice stone in there. If you have a whitening toothpaste, then you may find that there's actually volcanic rock in there, but a very small fraction only. So many cosmetic articles actually make use of this. And when I was a young man, there was also a new fashion coming up. It was stonewashed jeans. Now these are very kind of common these days, but back then it was a rather new thing. And if you think of the stone wash, it was actually pumice stone. So they were tumbled in a big barrel together with pumice stone, and it started to abrade the jeans. So stone wash jeans comes again from pumice stone. In addition to that, when you think of cultures all through the ages, we have millstones, and these are often made of volcanic rock as well. The advantage of volcanic rock is it sharpens itself when it actually mills the material, from milling grain all the way to other products. And here volcanic stone has been very, very famous. Already the Romans 2,000 years ago, they were quarrying, they were breaking rocks in volcanic areas to make millstones, and they were then exported all over Europe and in Scandinavia. The Vikings, for example, they bought their millstones from southern Germany, where there was volcanic rock. So this is a very important use of volcanic rock that people often forget. Now, I should also point out, I don't want to talk in much detail, but I should also point out that white gold, porcelain, or china, as some people call it, is also of volcanic rock. It's made of granite. It has a mixture of clay minerals, quartz, and feldspar. And if you mix them in the right way and you burn this in the right way, then you actually can make sealed porcelain. And this has been a huge improvement for human society, because suddenly we can wash things, we can wash plates hygienically. It makes all the difference. Imagine you have a wooden plate and you eat from it for many kind of weeks. At some point, it's not going to be so hygienic, but here with a porcelain plate, you can wash it. And this has allowed humans to increase our numbers dramatically and kept diseases at bay. The ability to clean instruments and dishes has
Hello,
gone
sir.
dramatic.
I want to ask.
I want to also kind of talk a little bit more about other materials we are mining and have traditionally mined. And here, of course, Kava again is a prime example, and that is sulfur. We have mined sulfur for many, many hundreds of years, and traditionally we mined it to make gunpowder. To remind everyone, gunpowder is a mixture of charcoal, potassium nitrate, and sulfur. And the Swedish government, for many wars in the past hundreds of years, was taking sulfur from Iceland. And many other cultures were mining sulfur. And sulfur is still mined, of course, at Kava Ijen. But it's not just for making dynamite and gunpowder. It's also for hygienic products and for making matches. And right now, we are mining less sulfur because sulfur is a byproduct of the petroleum industry as well. But if we go off fossil fuels in the next decades, then we will have to mine sulfur again. And volcanic sulfur may become very important again. So this could be something quite big for the future. We might need to go back to mining volcanic sulfur that we have almost stopped by now, but this may become important. And here is a mine, an old abandoned mine in northern Chile at over 5,000 meters altitude at a very remote volcano called Aucanquilchan. And this mine was abandoned some 60, 70 years ago. And here I think people will go back and mine again. And I think the Kava Ijen situation is going to serve as an example for sulfur mining in the world. I don't know what's going on. My slides seem to jump a little, but anyway, the next thing I'd like to talk about is geothermal power. Many people are not fully aware that volcanoes are, of course, allowing a lot of geothermal power applications. And here we have to remind ourselves what actually happens. And this is that hot waters are coming down, they filter down into the into the subsurface. They get heated up, and the steam that comes up can be exploited to either heat districts, to heat houses, or we can use it to make electricity. And one of the earliest power plants here is the one in Wairaki in New Zealand, and this is the picture in the top right. And there we have also a pipe system, and this pipe system, it clocks up with time, and this is the example on the bottom right, where we have one of the pipes that are starting to fill up with precipitation material. But if you replace the pipes repeatedly, it's gonna allow you to actually harvest the steam, the hot steam, for many, many tens of years. So, and here is some images from Indonesia. This is Salak in West Java, and this is a large geothermal power plant that delivers a lot of energy. And I had the pleasure of visiting there a few years ago. And this is something that is now also, of course, expanded. I know that there is a lot of exploration in Sumatra and in other places in Indonesia in order to harvest more of this very clean and very natural energy source. And of course, Iceland is a European example of a lot of geothermal power, because there we have active volcanism and a lot of water. And the Blue Lagoon, which is one of the big tourist attractions, is actually the pond of a geothermal power plant. It's not a natural lake, it's actually an artificial lake. And you can go there and you can bathe there, and it's going to cost you a lot of money, but it's very nice and it's very good for your skin. So, and there's the Svartengi power plant in the top left. That's the one that gives rise to the Blue Lagoon. And here, when we look at how geothermal power is used in Iceland, there we see that 40% is used for electricity. Another 40% is used for space heating. And then we have greenhouses, farming, and industry, and also swimming pools like the Blue Lagoon. So, and the Blue Lagoon sells a lot of cosmetic products, because the silicon mud that is produced from the geothermal power plant, it's actually very good for your skin. It dries out your skin. And if you go there, you can buy a lot of cosmetics. It's very popular, but it also is very expensive, but it's very popular. And apparently it's super good. I have not tried it myself, I have to say, but I was in the Blue Lagoon. And I think this is something that maybe people in Indonesia can explore as well, to maybe have some large bathing areas and make some cosmetics of it. But this is just me thinking, thinking loud. Now, talking more about what volcanoes do for us, I'd like to talk a little bit about salars in South America, because they're also from volcanic waters, or waters that have filtered through volcanic rock, and they dissolve a lot of elements. And what we need in the future, the next many decades, is we need a lot of lithium and boron for making lithium-ion batteries. And the waters there, they have a lot of these elements contained. And once the waters evaporate, we get these crusts of salt with very high lithium and boron content. And then, of course, we can quarry this, and this is done, and this may help us to produce enough lithium to make enough batteries in the future. But of course, there's also problems associated with this. It does change the groundwater level in these regions. It's not always popular with the local population, and we need to be very mindful about these two things, that we need to balance the needs of the local environment with the needs for global economy. And here's just a little picture I took a few years ago, and the tiny dots here, they're actually flamingos that live in this salar. It's very high. It's at several thousand meters in altitude, and it's very dry there, and the water evaporates very quickly. And this is not snow, this is actually salt. Only here on the volcano we have snow, but this here is actually salt crusts. And as I said, we need these elements to make, for example, batteries for electric cars. So this is another thing volcanoes do. But having said that volcanic waters are important, well, in France, for example, where I did my habilitation, that's the qualification you need in Europe to become a professor. There they sell you Volvic, volcanic water, and it's very clean water, and it's very good, and it's great for drinking. It tastes very well. and it's from the Auvergne, and there's old volcanoes, and the water filters through there. And there's a cosmetics brand in Vichy, that's a little town there, and the brand is called Vichy. And if you look at carefully here, it says here, from the depth of the French volcanoes, Vichy mineralizing thermal water is charged with 15 minerals. So they argue that the water is also particularly good, not just for drinking, but also for cosmetical purposes. So volcanic waters are particularly rich in minerals, and this is the point I'm trying to make here. Now, but having said this, I'd like to move now from these aspects a little bit more into the stones that people are using. And volcanic stone is very important, actually. We underestimate this very often. And traditionally, volcanic rocks have been used to build things on top of it, because often volcanic rock sticks up. And certainly here in Europe, people have put temples, churches, and castles on top of these things. And here are several examples from France, Austria, and Scotland, where castles and churches have been put on top of volcanic rocks to have a high point, a strategically high point, or a spiritual high point. And in addition to that, when the rock is soft, one can carve into the rock. And one of the UNESCO World Heritage Sites is in Cappadocia in Turkey, where people have carved caves into rock and lived there. And this is actually quite widespread. Here's another example from the Canary Islands. This is a rock that was carved out, partly weathered and partly carved out. This was likely a grain store for the Aboriginal people there. It is high in the mountains, it's very dry, it's very safe, and people have put the surplus harvest there in order to protect it. So, and here is another cave from Gran Canaria, the island of Gran Canaria. It's called the King's Cave, and this is one of the largest caves. And you can still go there today. And some of the caves even have restaurants inside. And it's quite attractive to go to a cave restaurant. And there's the entrance of one of them. So it's quite a special treat. And I think this is something volcanic rocks allow you to do. But having talked about digging into volcanic rock, I now like to talk a few minutes about taking volcanic rock and building with it. And this is, of course, something that people have done for many, many hundreds of years. And in Europe, many of the spiritual places are built of volcanic rock, of solid volcanic rock. And basaltic rock, the dark volcanic rock, is very sturdy, it's very strong. And the tufaceous rhyolitic rocks, they have higher silica, they often have many bubbles, and they are lighter, but still very strong as well. So you can build very tall buildings with them. And that's very, very attractive. You can build tall buildings that are not too heavy. They will not collapse into itself. So the trick is to use strong stone, dense stone, lower in the building, and use increasingly lighter stones higher up in buildings. And then you can build very, very tall. So, and this has been used, this is again from the Canary Islands. This is something the Spanish have used all over the world and exported this. So this was a church in a small village called Arico. And this concept has been used also in all of South America, actually. Many of the cathedrals in South America are built in this style with porous rock. And here I visited the quarry a few years ago. It's this red porous rock, and it allows to build rather magnificent places. And of course, this is something that has been used in Indonesia for many, many hundreds of years. And this is just two examples of large temples like Borobudur and Prambanan around Merapi, around Jogja. And here we use solid andesite rocks to build this, and these are from the 9th century, so well over 1,000 years ago, and magnificent structures, some of the largest temples in the world. These have been built entirely of volcanic rock. Having talked about the use of volcanic rock, I'd like to talk a little bit about the use of cement, because this goes back to the Romans. They were very clever. They used ground up volcanic material and they mixed it with water, and they realized that when it solidifies, it actually creates a chemical bond, and they used what is known as pozzolana cement. And this allowed to build magnificent structures. And of course, they were aware of the density of rocks, so they used very porous rock, like these fluffy rocks up here. You can see the inclusions, and here's a detailed example, a lot of pore spaces, but they were able to put it together with cement. And these structures are 2,000 years old, and they still stand today. So this is quite an amazing achievement, I must say. And of course, we use cement and concrete to this day. And this is something that requires a lot of materials. And in fact, there's a lot of discussion now to use more volcanic rock instead of limestone in cement, because this will be more friendly towards the environment. It will emit less CO2 if we use volcanic rock. So I know that companies here in Sweden, cement companies, are looking to use more volcanic rock instead of limestone as an ingredient in Portland cement, for example. Now, having said this, many cladding stones and stones for surfaces like kitchen surfaces or so are made of volcanic or magmatic rocks as well. And here's just a few examples. So here we have granitic rocks that make very good surfaces. They don't dissolve in water because they're silica based, so they will last for a long time, and you can clean them effectively. They also hold heat very effectively, so if your house is warm, they will stay warm, and if your house is cold, they will stay cold. So this is good for temperature balance in your house. And of course, this is something that we will continue to use for many, many decades. So having said this, I also like to talk a little bit about the use of aggregates, because what we mine the most per capita, per person, the most material we use is actually aggregates, gravel. And here's some gravel and sand mining from the slopes of Merapi volcano again. So this is very young deposits, pyroclastic deposits, and it's mined, and the material is used for building, supplements, and for agriculture. And it looks a little disorganized at first glance for those people not familiar with it. The miners there, they purposefully mine this in a big angle, in a strong angle to the flow direction, because what it does, it creates a sediment trap for the next pyroclastic flow. So the next pyroclastic flow will slow down because of the ripple effect. So not only are they extracting material for industry, they're actually helping hazard prevention by doing this. So I thought it was a very clever way of killing two birds with one stone. So, and then of course, I'd like to talk a little bit about aggregates here. And we use a lot of aggregates to put into cement. And this is an image here from the Canary Islands again. And all of these buildings here are built of concrete, but about half of it or more is actually volcanic stones put into the concrete. So if you look at these houses, you must realize there's a lot of volcanic stone in these rather colorful houses here, and we mix that into cement, for example. But having talked about primitive housing now, concrete supplements and abrasives, like in jeans production, I want to talk a little bit about agriculture in the last part of my talk. And this is agriculture and gardening, because this is how we make food. And this is, of course, extremely important as well. So this is something that I'm very interested in, and that is the science of, or the history of science. And there was a German researcher, Mr. Humboldt von Humboldt. He visited volcanic areas already several hundred years ago, and he went to the Canary Islands in 1799. And what he realized here on the island of Tenerife was that there is a change of vegetation with altitude. This was really important. What a spectacular observation. And he realized that we have different types of plants the higher we go. All of them grow on volcanic rock and soil, but there will be a change. And the higher we go, the more it will be like at the North Pole. So on top of the tall volcano Teide, it will be almost as cold as in Arctic Sweden. And down at the coast, it will be warm and there will be palm trees. So this is, of course, a concept that he then described in detail. And here on the right, you see the palm trees, and then the vegetation gets less and less. And as you know yourself, on tall volcanoes, there is no vegetation on top. Merapi has no vegetation on top, for example, because it's too tall. It's 3,000 meters tall, and the trees stop at some point. So this is important. You need the right climate, the right rock, and the right amount of water, and then you can make a lot of food. And to stay with the Canary Islands, here's Teide Volcano from an old postcard here. And this is the Orotava Valley. It's one of these large valleys, and there a lot of banana is grown. And here down at the coast, the climate is just right, the soil is just right, volcanic, very fertile volcanic soil, and there's a lot of rainfall, and that means you can grow a lot of food there. So having said this, here again, I worked on Merapi a lot for the last 20 years, and if you look at Merapi, there's no trees in the higher part because it's 3,000 meters tall. The trees stop here, but low down, we have a lot of fertile land because we have fertile soil. We have a lot of rainfall in the rainy season, and it's warm. And then you can grow a lot of food, like here, a lot of rice paddies here in the lower part, but also forests and things like that, very lush. And this, of course, allows to sustain large populations. I should actually point out that people realized this quite some time ago. It's not just something that Humboldt realized. This is one of the oldest food advertisements I could find. It is from Italy. It's actually an advertisement for olive oil. And it goes back to 1787. And it says that the olive oil is particularly good because it comes from Vesuvius volcano. So here's Vesuvius volcano. And here it says, buy our olive oil effectively. So having said this, I mean, many spices are, of course, grown, particularly in Indonesia. And here we have chili peppers, and this makes for beautiful spicy foods. And you can even buy Krakatoa pepper here in Europe, which implies that it's very good pepper and very spicy. So tropical spices are, of course, often grown on volcanic soil. And I should also point out, a lot of coffee is grown on volcanic soil, and people in Cava Ijen and in the Ijen caldera area, they know this very well because there's a lot of coffee being produced there. And here you can buy in Sweden in the supermarket, you can buy Blue Java coffee, and it's one of my favorite brands. And here I should point out that Sweden drinks a lot of coffee. So this is domestic coffee consumption. And here's the highest domestic coffee consumption in dark blue. So Sweden, Norway, and Finland, together with Iceland, drink the highest coffee per person. And obviously, we don't grow coffee here. So much of it comes from volcanic areas like South America, like Africa, and of course, also Southeast Asia, like Indonesia. So I love a lot of coffee, and I drink a lot of coffee. And this is, of course, something that is very important. And 70% of all coffee is grown on volcanic soil. And here's a few images. This is actually from the Ijen caldera, which I took a few years ago. Here's a few coffee beans that have grown at Ijen. And of course, I went also to test the coffee there, and I like it a lot. So here's just the history of coffee. You know this better than me, but here's the beans. And the beans are white, actually, and then they have to be roasted. And then you can make fantastic coffee here. So I always bring a lot of coffee back home when I visit Indonesia. So here is other kind of things that are grown, other types of beans. This is chocolate. And this is actually from the slopes of Merapi volcano, where chocolate is farmed, and it's very tasty. But here is cocoa beans, and that makes, of course, volcanic chocolate then. I've recently had the pleasure of visiting Hawaii, and this was exciting. I've never been to Hawaii before, but Hawaii has very red, oxidized volcanic soil, and it grows there for a lot of fruit. So here is mangoes and pineapples, and the big Dole company, one of the biggest pineapple companies in the world, it actually comes from Hawaii. So, and there's a reason for that. And the small print here says it's the volcanic soil that makes it possible to grow these beautiful pineapples and mangoes. So, and of course, tea is also important, and tea is also grown in highlands particularly, and often in volcanic highlands. It's less clear with coffee, but than coffee. But tea is also a product that often requires volcanic soil. And here, these plants, this is something that people are more controversial about, but I guess you all recognize the plants because this is tobacco, and this is young tobacco, and this is mature tobacco. In fact, this is also pictures from Indonesia, and tobacco has many uses, and traditionally, of course, people are smoking it, but smoking in many parts of the world is becoming unfashionable. Although personally, I still like to smoke a cigar when I celebrate. So when my children were born, I was smoking a big cigar, but I stopped regular smoking a few years ago. So tobacco is also grown on volcanic soil very frequently in Indonesia, in South America, in the Canary Islands, and other places like that. So, and here also it's grown in Hawaii, as I learned recently. So this is Volcano cigars from Hawaii. They are grown on the island of Maui. And I did try one of the Hawaiian cigars when I was there, but they were flavored with vanilla and coconut. I didn't like it quite so much. So, and a few words now about what the secrets are of these volcanic soils. And here, as I said, there is the volcanic soil, there is the climate and the water. And if you mix them together, you get wonderful results. But as a scientist, we do experiments, and there's a natural experiment about what happens without water. If you only use warmth and volcanic soil, and here the Canary Islands are very useful. There was a big eruption in one of the Canary Islands on Lanzarote in the 18th century, 1730. And here people realized that once the volcanic areas are covered with little volcanic stones, then you actually get more fertile growth. So after the devastating eruption of 1730 to 36, people realized there was more blooming than before. And that meant the volcanic addition, the volcanic particles were the secret here. And since that eruption, people there realized they can grow many things, and they grow a lot of wine there now, and they grow potatoes, and they grow all sorts of other fruits like dates. And this has been allowing the population of the island to double within a few decades. So this material there is called pecan, that's the local name, and it's used as a mulch. It's put on the fields and it changes everything. Suddenly a lot more crops could be grown after this eruption, and within 5 decades the island's population doubled because we had so much more food. And here you see in the valleys they still have fields with a lot of the volcanic material being added, and sometimes they dig these little holes and put the plants in there, so the wind passes over, the wind cannot damage the plants, and they can actually access the ground. But what is actually the secret of the volcanic rock is one of the questions I was asking. And well, one secret is volcanic rock has little bubbles, it has little vesicles is the technical term, and here it's quarried in many places, like here in the Canary Islands. And if you leave it packed in these bags, for example, and the next morning you come back to it, and after it cooled down, you realize there's a lot of water in there. It's a lot of water because obviously they packed it dry, but there was water inside the rock in the little vesicles. And that's what's very good for the plants, because these volcanic particles, they keep the water in. And that's, of course, very useful. There's another secret, and that is we've been looking into some of these samples of volcanic particles, and this is now electron microscope images. And here's one of these vesicles here, a volcanic bubble inside a rock. Here's another one. And if you look carefully, there's microorganisms in there. And here, this is huge magnification. We are really looking into quite some detail. And I'm not a specialist what these organisms are called, but I asked a specialist, and they identified all these different animals. And here's the names, the Latin names, and there's a publication. You can read the details on it. But there's actually a lot of microorganisms that live in these volcanic rocks inside the soil. And that means they provide a lot of material from the rock to the plants. So it's not just the plant interacting with the rock. There is an agent, the microorganisms that help to break down the rock and supply nutrients to the plants. And these organisms, they actually need CO2, and that means they can fix a lot of CO2 in the soil, and the rock that weathers will also fix CO2. So there is some people that argue, if we think about climate problems in the future, maybe using more volcanic rock on agricultural fields might actually help a lot. And here is some plots from a paper by Bierling and others, and they made some calculation for many countries in the world. And they say if we use more volcanic rocks on fields, then we can fix a lot of CO2. And here's also the example of Indonesia. They calculate that 20% of the Paris Agreement CO2 emissions could be fixed in the soil by using more volcanic rock on the field. So that's a very cheap way of fixing part of the problem. And it seems to be true for many countries and to different percentages. But this is something to think about, that we can use more volcanic rock in agriculture. And it might not only produce more food, it might also be good for the environment. So, but here's a few more exotic things, and that is here I've just been involved in the La Palma eruption, a big eruption in Europe. And here's the La Palma cone, and it erupted. And I have a little video here. Not sure whether this translates well, but here we see a lot of ash being produced from the volcano. And here we have a little house that was at the bottom of the volcano. Only the chimney is left. The house is completely gone. Here we have a traffic sign. It's completely gone. And there is so much ash that people will, of course, put it on the field. But what else can you do with it? And just on my recent visit, I saw that people are now making soap from the ash. So I thought this was a wonderful idea. And it says, of course, it's very good for you because it's exfoliating. They're using this concept of the pumice stone. Why is it exfoliating? Well, if you look at the ash, and there's a lot of ash on La Palma, you can look at it in detail. And of course, the ash has tiny little sharp edges from the vesicles. It has holes as well, but it's got a lot of sharp edges. And that what can be used to scratch you, to exfoliate your skin. So technically you're scratching your skin and therefore you're removing it, at least in those parts where you have excess skin. So I thought this was a wonderful idea. And just to close off, a few words on the last major resource volcanoes provide, and that is volcano tourism. This is a growing thing all over the world, and this is of course important for Indonesia as well, and in particular for the geopark at Kawah Ijen. And the Ijen Geopark, I think, will be an increasingly important tourist attraction. And this, of course, goes back to places like Hawaii down here, where people are going for holidays right in the 50s. And then many other places where this is, of course, important, the Canary Islands or Iceland, for example. And here you have jeep safaris at Merapi, or you have volcano skiing in Cerro Negro. And of course, Mount Fuji is our tourist destination for all sorts of reasons, also spiritual reasons. Tourists at Stromboli here, that is almost continuously erupting. And this is, of course, a huge financial resource. In fact, people argue that during the pandemic, Iceland might have gone bankrupt, but there was an eruption and many people came, and this may have actually saved the economy of Iceland. So here's just some examples going back from national parks and all sorts of new ideas. You can have volcano tours in Iceland, in Indonesia. In Hawaii, you get even theme park kind of things. There's a military camp if you like that sort of thing. And of course, this goes back to the Canaries here, where you have volcanic experiences. So this is very widespread, and I think it's a big thing to come. There is a downside. I need to state that. I've just been to New Zealand recently, and there was, of course, the White Island disaster just recently. And there people died because they went too close to the volcano. They were not particularly careful. And then a whole range of people suffered badly and some died. And there's now a big court case because of that. So, and of course, they make beautiful national parks. Just to really finalize my talk, One of the biggest national parks in Europe is the Teide National Park on Tenerife, with more than 4 million visitors prior to the pandemic. And this is the most photographed rock in all of Tenerife. It's called the Tree of Rock. It's volcanic layers, but it's eroded. It's an older rock, but it stands proud. At some point it will fall over, unfortunately, but maybe not in the next few years. And here I think that we want to actually think about more national and geoparks, and this is why I'm so happy and delighted about the Agen Geopark. And I think actually on La Palma, where the recent eruption was, there should also be a geopark. I think many of these features should be preserved instead of building over. And actually, this is Harry, the person who is helping here, who is in the audience as well. And this is one of the lava flows that went over one of the roads. And I think hopefully they make a geopark of that. So I'd like to summarize now. We have talked about metals and ores. We have talked about gemstones. We have talked about sulfur mining, building materials, abrasion materials, geothermal power. And we've talked about food and drink and cosmetics and geotourism. And we even touched on whether volcanoes can help with climate issues. So all of these things are important. And I cannot stress enough that volcanoes are not just bad. Volcanoes have two sides. If you're too close, they are of course not good for you if they're erupting, but they provide a lot of what's nowadays called ecosystem services. And here's the international classification of ecosystem services. So here I'm just showing the important ones I talked about today, and that is about water, chemical agents, geothermal energy, metals, building materials, etc., and even recreation and ecotourism. And of course, I like to think volcanoes make the best coffee in the world. And for me, it's afternoon, so I think I'm ready for a coffee very soon. And I'd like to thank you for your attention. And I hope you found this a little bit of interest.